Outline how you would distinguish between the following substances using only litmus paper, water, and Tollen's reagent. In your answer, you should also include the name of each molecule, the test you would carry out, and any equations if applicable to identify the organic products formed. Now, how can we distinguish them? This first compound is an amine, and we can use litmus paper. Amines are basic, right? They're weak bases, rather like ammonia, weak bases. So they'll turn moist red litmus blue. So that let's check if there's any other base here. Aldehydes are neutral compounds. These ones react violently with water, and propanone doesn't get oxidized. Okay, so the first thing, the way you'd actually do this, you'd take a drop of each of these compounds and add it to water. The only one that reacts violently with the water is this acyl chloride, also called an alkanoyl chloride. So that will react violently with water to produce fumes of hydrogen chloride. So add water to samples of each of the compounds. The only one that reacts violently to produce hydrogen chloride fumes is the CH3COCl. Right, so you've identified that one. Okay. Next, take moist red litmus paper. The only one that turns it blue is the propanamine. This one here, propan-1-amine is how we should actually name it systematically. Meth et prop, the amino group at the end. So propan-1-amine, also called 1-aminopropane. Right, so you distinguish that. So we're down to these two compounds here. An alkanone here. That's the ketone there. Remember, the C double bond O is not at the end. And that's an alkanal. Clear situation where we can use Tollen's reagent. You could also use Benedict's or Fleming's. Either way, the alkanal gives the positive result, in this case the silver mirror, whereas the alkanone does not react. So you have distinguished each of these four compounds. Right. Now the name of each molecule. The first one here is 1-aminopropane, or you could call it propan-1-amine. Either name is correct. This one here that I'm pointing to now is propanal, and no one needed there because to be an aldehyde or an alkanoic acid, it has to be at the end. Propanal, that's it. This one is 2-carbon alkanoyl chloride. So it will be ethanoyl chloride, ETHANOYL, ethanoyl chloride. And this one here is propanone. So the name of each molecule will be given the test, and then any equations if applicable to identify the organics products formed, that's in these tests. So here we are. When you add water to the amine, I told you it is a weak base, and here it is. Rather like ammonia, what it does is it gains an H plus from a water molecule. So we'll end up with CH3, CH2, CH2, NH3 1+, and the Lowry-Brunstad acid-base theory, the H plus came from the water molecule, so that becomes OH minus. Okay, so that's the reaction when the amine dissolves in water to give you this ion and OH minus. Think of it rather like NH3, where one H has been replaced by an alkyl group. And this is like NH4 plus, where one hydrogen is replaced by the alkyl group. And then OH minus. So it's a weak base. Now here's the silver diamine test reaction. I told you it's capable of oxidizing an alkanal to an alkanoic acid. However, these conditions are alkaline. So under the alkaline conditions, you end up not with the alkanoic acid, but its conjugate base, the propanoate ion and not propanoic acid. How do we know that? Because these conditions, it's in an ammonia solution. So that's going to be alkaline. So you can think of it like, okay, you get the alkanoic acid and then that will react with the base because this is ammonia solution to give the propanoate ion. Okay, so that's that note here, propanoate ions and not propanoic acid because of the alkaline conditions. So remember that. Now, by the way, I think in your suggested answers to the exam paper questions, I think that was one where it was wrong. They actually put the hydrogen there. But when you explain it like this, they'll see that this is in fact the correct situation because it is the propanoate ion under the alkaline condition. Alkanoyl chloride here, I told you it reacts violently with water to produce fumes of hydrogen chloride, HCl gas. Why? Because the OH comes onto here. Remember, with an alkanoyl chloride, it's very easy to produce the alkanoic acid because the OH comes on there to replace the chlorine and you get hydrogen chloride gas. So the hydrogen chloride gas with any moisture produces those fumes that you can see in the air. Okay, any question about any of those? You can either type it through or I can give you the microphone to ask the question. If we forget to put the equilibrium arrows for the first equation, will it be marked wrong in the exam? Good question. Yes, you will lose marks. You won't get the full mark for that. Because when you put that arrow to completion, and there'll be a lot more of this coming up between now and the end of the course when we talk about the acids and bases, so I don't think you'll be making this mistake. If you put that arrow to completion, that means it's a strong base, like sodium hydroxide, potassium hydroxide, amide ions, that type of thing. But this is certainly not, it's a weak base. So therefore, it's an equilibrium.